All right, question number 25, and you see this is from the second half of the first year syllabus. It's made from the topic wave, and more precisely, this is related to experiment and measurement. The same thing which I have been repeating, that any topic related to experiment, any topic related to measurement, that has to be taken with additional care. This is the famous resonance column experiment, and let's see how are we going to go with that. The tuning fork has frequency 480 Hz, and it is used. The first resonance occurs at 30 centimeter, the second occurs at 70 centimeter, and on the basis of this data, I need to calculate the speed of the sound. All right, now what we can write is that L2 minus of L1 would be equals to lambda by 2. That's a very standard fact because L1 occurs at lambda by 4. L2 occurs at 3 lambda by 4. And when you subtract, that comes at lambda by 2. And the frequency is already there, which is 480 Hz. Now it's so simple. With the help of this, you calculate lambda, there is frequency. So the speed of sound would be wavelength multiplied by frequency. And it's almost verbally done. Option number 2 would be the correct option. That was question number 25. Let's move to question number 26. Question number 26 has more inclination with mathematics and a very nice integration is involved. But by the time you come to appear for JEE Main, you are already well versed with all the integration skills, so this should not be a trouble. Let's see, the number density of molecules of a gas depends on their distance r from origin as this. So this is the number of molecule per unit volume, and you could see the distribution depends on r. That means the distribution has a spherical symmetry. And we need to calculate the total number of molecules. That means extending from r equals to 0 to r equals to infinity. To do that, what we will see is that total number of molecules, let's see, that is going to be integral n naught e raised to the power minus alpha r raised to the power 4 into 4 pi r square dr. And what would be the limit? Of course, the limit is 0 till infinity. That's the limit of r. Now you could see this involves a very nice integration. And I would not be going through all the steps of integration, but yes, I am certainly going to give you the small hint that if you do it by substitution, you need to put the value of root alpha r square as a new variable, and let's say that variable is t. So once you put this thing, you could say that root alpha 2r dr will be equals to dt. So it's integration by substitution. Ultimately, the question required the total number of molecules, proportionality that has been asked, and once you do this, you solve it, you're going to get option number 1 as the correct option. It will certainly require a strong presence of mind and you need to solve it very carefully, but not a difficult one at this level. Fair enough, let's go to the next. Question number 27, the circuit is very clearly given in front of you and the question is a verbal one. Maybe the examiner thought that immediately after question number 26, which was a nice mathematics, just to give you a slight relaxation. So if that was the thought process, that's really welcoming. Now let's see, this is the circuit here and the question requires to calculate the charge on the 4 microfarad capacitor here. Now let's say this is 5 and 1 parallel, so that will be 6 microfarad, right? And 4 and 6 microfarad, what would be the series combination? That's certainly going to be 2.4 microfarad. And that is fed across by 10 volt, so the charge has to be 24 microcoulomb. So option number 4 is the correct option. That was a very straightforward, a nice bonus. Let's go to the next.